So today we're going to talk about box and whisker plots. In your textbook, they call them box plots. They're the same thing. You'll see why in just a minute when I show you a picture why they might be called box and whisker plots. I'm going to tell you that this is probably a new type of display. Your parents probably did not learn this in school. When I started teaching about 20 years ago, this was not something that was taught. So this is a very new concept. It's not difficult. It's actually quite handy when you go to compare two different populations of the same information. It's also very handy when you've got a large data set that you can look at chunks of data at a time. So we're going to go through some vocabulary and then I'll show you how to make one of these. All right, so the vocabulary, you need to be able to find the minimum, which is the smallest number on your list, and you need to be able to find the maximum, which is the largest number on your list. Sometimes these are called the lower extreme and the upper extreme. We know them as max and min, or min and max. The median we've been studying for a couple days now. It's the middle number when you arrange the data in order. And then there's something called a quartile. Now, if you know the word quart, which is a unit of measure, or quarter, or maybe even quad, thinking of like the bike that has four wheels, you're going to split the data into quartiles, which means you're going to split the data into four equal-sized parts. The lower quartile is the lower of those four pieces. Sometimes it's called the first quartile or Q1, or even the lower median. And then you've got the upper quartile, which is the upper part of those fourths, sometimes called the upper median, the third quartile, or Q3. Now, we don't talk about Q0, Q2, or Q4 because those are the min, the median, and the max. We only call Q1 and Q3 because we don't have any other names for them. And then we've got an outlier. We've talked about this with some of our other graphs. If you've got a data value that is significantly different from the rest of them, it might skew your data a little bit. And I'll show you an example of how that can affect it in a few minutes. And then, of course, we've got the box and whisker plot, or just a box plot. It is a visual representation of data, and it is helpful when you want to compare sets of data. And there's what one looks like. So that lower extreme, or the minimum, sometimes you'll see dots. I've actually used lines in the examples that come later. Here's our median. I'll come back to the other one in a minute. Smack dab in the middle. Half of the information is down here, and half of the information is up here. We've got our upper extreme, or max, maximum. And then we've got our quartiles. Here's what we would call Q1, or the lower quartile. And here's what we would call Q3, or the upper quartile. When we talk about quartiles, we talked about fourths, or four equal-sized pieces. 1/4 of the data is contained between the dot and this first line. 1/4 of the data is contained in this first boxy section. 1/4 of the data in this second boxy section, and 1/4 of the data in this last line. Now, it doesn't look like these are the same size. They contain the same amount of data, but they might be stretched out because of the type of number that's there. Okay? All right, how to make it. You're first going to put your data in order from least to greatest. Then you're going to find the 5 key numbers, the minimum, the maximum, the median, and the Q1 and the Q3. You'll make a number line and mark those 5 key numbers that you just identified. And then you'll connect the middle 3 as a box, and then connect the box with the whiskers to the min and the max. All right, let's look at an example. There's some fancy motion happening here too. I got really excited when I made this PowerPoint. So here's our list of data at the top of the screen. We're going to put these in order from least to greatest. By the magic of technology, ta-da, there it is. We're going to identify the numbers. There's the minimum. There's the maximum. Put a finger on each end and move in. Our median happens to be smack dab in the middle of it. Okay, so when I go to do the rest of them, I will count the 80 in the numbers below, and I will count the other 80 in the numbers above. Like that. Then we'll find the median, put your fingers on each of the ends again and move in until we get to the one in the middle. In this case, Q1 is going to be 70. And the same thing on the other half, put a finger on 80 and 100, move in, you land both on 90. That would be the median of the uppers, or the Q3. All right, the next is to mark the numbers on the number line. Fancy, fancy, fancy movement. There's the number line. I'm just going to make a line for each one of those. There's 65, 70, 80, 90, and 100. Now, the one example that I showed earlier, this was a dot and a dot. You can do that if you prefer. I like the lines because they're all the same. Our last step is to connect the middle three as a box, and then to use lines to connect them to the outer ones. There you go. We've made a box and whisker graph. Quartile, think quarter or 1/4. Some other names, lower quartile is sometimes the lower median, and the upper quartile is sometimes the upper median. If you remember those words, it might help you remember what to do. And sometimes this is known as the 5-number summary, which is handy because you've got 5 fingers on your hand. I know, I got really excited with my animations when I made this. All right, let's do another example. Another list of information. By the magic of technology, poof, I've put them in order for you from least to greatest. We'll clear the original out, and here we go. So if you remember, we have to find 5 things: the minimum, the maximum, the median, and then the Q1 and Q3. So our minimum is 1. I'll show you this in a second on how we're getting these, get the numbers up here. This should actually be a 10.5. 10 is close enough for what we're doing, but it does fall smack dab in the middle of it. So when you find your median here at 6, because it has one number, I will not include that when I find the median below it. So I will use the 1 through 5 here, move in until I find right here in the middle. And the same thing, I would not include the 6. From the 7 to the 34, I would move in. It is right smack dab in the middle here at 10.5. Now notice I have the asterisk here at 34. This is what we're going to consider to be an outlier. It is significantly different than the next number to it on the list. There's my number line. I'll mark each of my numbers that I found in the 5-number summary. Connect the middle 3 with a fancy dancing line, and then connect the other ones. Notice how stretched out this is. Between this bar and this bar is still 1/4 of our data. It looks like it's a bigger section because this outlier stretches it out so much. And even down here, this little teeny tiny whisker, 1/4 of the data is contained there. So you can see, because this is kind of compressed, we've got a lot of numbers that are very similar. And because this is stretched out, we've got a lot of numbers with variation to them. Here's what it might look like if I exclude that outlier. If I say, let me ignore that 34 for a minute, recalculate my min, Q1, median, Q3, and max, ignoring that 34, this is what it would look like. Now, in statistics, you can't ignore numbers. So I still need to say, well, there was another number here, but I didn't include it when I calculated this. Look at how different these two graphs are. It's the exact same information. Down here, it looks like they're a little bit more evenly distributed than up here with this 34 stretching this out so far. Okay, let's switch to the textbook. I am going to be on page 882, and I'm going to walk you through and make one of these, and then you can practice a few on your own. So our first step is to order them from least to greatest. We're going to talk about the depth of earthquakes, how far down into the ground the shaking happened. So I'm going to put them in order. 1, 2, 3, 4. I have a couple duplicates here. I will count them each time. Then it looks like we jump to 7s, some 9s, 10, an 11, and a 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. 2 layers makes 14. I like to count to make sure that I got them all. Okay, now we're going to find our minimum, our maximum. I'm going to put a finger on each end and move in to find, wait, 1, 2, 3, to find the median. Now, my fingers landed on 5 and 7, so my median is going to be the average. Add those up and I get 12, divide by 2 and I get 6. Because it wasn't one number, that 5 will be included in the lower data, and the 7 will be included in the upper data. All right, so let's ignore the top part for a second. I'm going to start at 1 and 5 and move in and move in and move in. I landed on 4. Start on 7 and 15, move in, move in, move in. and I landed on 9. So the numbers that I'm going to mark on my number line over here, conveniently made for me, I'm going to put a line at 1, a line at 4, a line at 6, a line at 9, and a line at 15. I'm trying to keep them all pretty much about the same size. Then I'll connect the middle 3. Now, if you have trouble seeing this, maybe you connect your whiskers first, and then you can go back and connect and make your box. And there you have it. You've made a box and whisker plot.